What if I want to add to a full array? Or remove an element from the middle? What if I don't know how big my array needs to be? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 47th video in the Introductory Programming in Java full course, and the 8th video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In this video, we're going to look at a data structure that solves some array limitations, the ArrayList. Let's get right into it. The primary limitation of an array is that its size can never change once you've defined it. An ArrayList solves this limitation. It can grow and shrink as needed, and even allows for insertion and removal within the data structure, not just at the end. You can even convert an ArrayList to an array if you need to pass it to a method that requires an array as input. In one of our early array programs, we read integers from a file representing the number of countries protecting core LGBT rights by decade. The data is from Equaldex and OurWorldInData. I'll put a link in the description. This is a good example for an array list because we often don't know how many values are in a file before we read it. Let's look at this same program but implemented with an array list. I have them side by side for comparison. The ArrayList class is in the Java util package, so we need to import it at the top of the program with import java.util.ArrayList. Now most of the program is the same. We check if the file exists, and if it does, we create a scanner and read values in a loop. After the loop, we average the values. Let's focus on the parts of the program that use an ArrayList and see how that differs from using an array. First, the variable declaration on line 12. This syntax is unlike any syntax you've seen so far. ArrayList, open angle bracket, integer, close angle bracket, values. What's new here? The angle brackets, which indicate a generic type, and the integer data type. Notice we've spelled out the entire word integer and it begins with an uppercase I. Let's look at how to use ArrayLists first, and then we'll discuss generic types and primitive wrapper classes like integer. Once we've determined the file exists, in the old program we create the array using the new keyword, the data type, and the size of the array. This allocates space for max values integers and initializes them all to 0. In the new program we allocate space for the ArrayList using new ArrayList, open angle bracket integer, close angle bracket, open paren, close paren. Again, we use the angle brackets and put the data type of the ArrayList in the angle brackets. Notice also that we're invoking a constructor here. Except for the angle brackets, this looks similar to creating a new scanner or file or object of our own programmer-defined type. We invoke a constructor. We don't invoke a constructor for our array explicitly because Java includes some syntactic sugar that makes an array look a little bit more built in. Notice also that we don't specify a size with our ArrayList. Our ArrayList will grow or shrink dynamically. It will always be exactly the right size to hold its data. Now to add an element to the ArrayList, we send the add message to the ArrayList variable. In the old program, we have value array subcount equals the value we're reading from the file, filescanner.nextInt. In the new program, we invoke the method values.add, parentheses, and then the parameter is the value we're reading from the file, filescanner.nextInt. We will never be indexing into an ArrayList the way we index into an array with square brackets. We'll always be sending a message, such as add. In our old array filling algorithm, we keep track of the next available location in the array with an indexing variable, in this example count. We then replace the value already at that location with the value read from the file. When we initialized the array, it was filled with zeros. When we create the ArrayList, however, its size is 0. We're not replacing a value when we send the add message, we're adding it to the end of the ArrayList. After the first iteration of the loop, the ArrayList has a size of 1. The array has a size of max values, but we've only put count, or 1, value in the array so far from the file. The other 49 locations in the array are filled with zeros. After we read all of the numbers from the file in the new program, we have an ArrayList containing 70 values, the number of integers in the file. Whatever size the file is, that will be the size of our ArrayList, unless something catastrophic happens during program execution, like the file being deleted while the program is running. Let's compare the entry conditions in our loop headers. When adding values to the array from a file, we must check both that we haven't run out of values in the file to read, and we haven't run out of array to store the file values in. But when adding values to an array list from a file, because the array list doesn't have a fixed size, we need to check only that there's something in the file to read. Finally, let's compare the code that averages the values that we've read from the file. In both programs, we're looping over all the values we read from the file and adding them to a total. In both loops, we have a loop control variable I, and we're using the size of the data structure to control entry to ensure we don't try to index past the end of the array or array list. For the program with the array, because we may not have filled the array, our test is I less than count and I less than value array.length. For the program with the array list, the test is I less than values.size. With the array list, we don't need to check the number of values we read because that's the number of values in the array list. Note also that an array list does not have a length field that we can access. To get the number of elements in an array list, we use the size method. This is a very efficient method, so don't worry that we're invoking a method here rather than accessing a field. It's simply returning the value of a private field. Within the loop, we access the element we want with the index I. In the array example, we use the square brackets and index into the array with I. In the array list example, we use the get method and pass the parameter I. This method will return the value in the array list at index I. Once we've accumulated all of the values into the variable total, we average them. In the array program, we divide by count, the number of values we read from the file. In the array list program, we can divide by values.size because the size of the array list is the number of values we read from the file. We will look at some other methods in the ArrayList class, but before we do, we need to go back to that ArrayList variable declaration and explain generic types and the integer wrapper class. Our ArrayList variable declaration looks like ArrayList, open angle bracket integer, close angle bracket values. Let's start with integer. Integer is what's called a wrapper class in Java. It wraps a primitive type, in this case int, inside an object so it can be used in places where objects are required, like in an array list. Java has a wrapper class for each of the primitive types, integer for int, double for double, character for char, and so on. Even though ArrayList integer holds integer objects, Java makes it feel almost like you're working with regular int values, thanks to a feature called autoboxing. Java automatically converts an int to an integer when you add it to the list. Similarly, when you retrieve a value from the list, Java automatically converts the integer back to an int. This is called unboxing. This means you can write code like values.add, filescanner.nextInt, and total plus equals values.getI without needing to explicitly create or unwrap integer objects. Behind the scenes, Java handles the conversion for you. And the reason we need to use a wrapper class here is because the elements in an array list cannot be primitives. They must be objects. But there are wrapper classes for every primitive type, and with the autoboxing and unboxing, you can treat them like primitives. Now let's talk about the angle brackets. The angle brackets after ArrayList indicate that it is a generic type. A generic type is a data type that can be parameterized with a type, as we're doing here, parameterizing ArrayList with integer. The type parameter goes inside the angle brackets. An ArrayList is one category of generic type that you'll find in Java, types that are collections of other types. Another example is a hash map, which you may have briefly noticed in the choropleth map example a few videos back. You can also create your own generic types. What this means for us learning to use ArrayList is that we must put the data type that will be stored in the ArrayList within the angle brackets, and it must be an object type. It can't be a primitive type. And then we can add objects of this data type to our ArrayList. Now let's look at a table of ArrayList methods so you can learn a little more of its functionality. In this table, we're assuming an ArrayList of string objects for a little variety. You're already familiar with add, get, and size. The next method in the table is equals. You can pass an ArrayList to another ArrayList's equals method, and it will return true if the objects in the ArrayLists are the same and in the same order. This invokes the objects equals methods. The indexOf method is our sequential search, essentially. It will return the index of the first instance of the object you pass as a parameter, or it will return -1 if it doesn't find the object in the ArrayList. Now, you can remove an element at a specific index in an array list, or you can remove a specific object from an array list. You can see there are two remove methods here. One takes an index, and the other takes an object to be removed. The object will be removed, and then all of the other objects, if there are any to the right of the object, will be shifted left. The set method takes an index and an element as parameters, and replaces the element at index with the element passed as a parameter. This is equivalent to assigning element to array sub-index. And finally, you can turn an array list into an array, but there is a catch. You will be creating an array of objects. With our array list of integer, we can use toArray to create an array of integer objects. If we want to convert to an array of primitive ints, we will need to write the code ourselves and do it with a loop. There are other ArrayList methods, including variations on these methods. I'll include a link to the ArrayList documentation on Oracle's website so you can explore them yourself. In this video, we looked at the ArrayList class, an alternative to an array that can grow and shrink as needed. We looked at an ArrayList version of a program we'd previously written that reads integers from a file into an array and then averages them. We learned that you must use methods to access and add to an ArrayList. We learned that ArrayLists cannot hold primitive values, but there are object wrapper classes for all primitive types, so we can store primitive data in an ArrayList. We learned that ArrayLists are generic types, meaning they can be parameterized with a data type. The syntax for that uses angle brackets following the data type ArrayList, with the data type stored in the ArrayList inside the angle brackets. We then looked at a table of ArrayList methods and the equivalent array implementations, where applicable. I hope you found this video interesting and helpful. As usual, I've included an auto-graded exercise in the description of this video so you can practice with this code. And the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.